Right, in the past, you have written and evaluated expressions with exponents such as 5 to the third and x squared plus 1. Now take a look at this problem. Multiply 3 to the third times 3 to the fourth. Use the math you know to answer the questions. What do the expressions 3 to the third and 3 to the fourth have in common?
The base is the same.
The base is the same. They have the same base, and that base is the 3. Write a multiplication expression without exponents that is equivalent to 3 to the third. When they say a multiplication expression without exponents, they mean expanded form. So if we was going to do that, we would take the base and we would write it 3 times. 3 times 3 times 3. So how many factors of 3 did I write? 3. Good. Write a multiplication expression without exponents that is equivalent to 3 to the fourth. We're still doing expanded form because it says without exponents. The base is 3. We will use it 4 times. How many factors of 3 did we write this time? 4. F, write a multiplication expression without exponents that is equivalent to 3 to the third times 4 to the third. So we're going to expand the first one, 3 times 3 times 3. Then we're going to multiply it by the expanded form of the second one, 3 times 3 times 3 times 3. How many factors of 3 did I write? Write an expression with exponents to complete the equation 3 to the third times 3 to the fourth. We had that base of 3, and then the 3 and 4 made 7. I and J are basically the same question. We're just going to answer them as one. What is the relationship between the exponents of the factors and the exponent of the product in your equation? Use words to explain how to multiply 3 to the third times 3 to the fourth. The rule here is keep the base the same. Keep the base. And do what with the exponents? Add the exponents. So we would keep the 3 and we would add the 3 plus 4. You have seen one example of how to multiply powers with the same base. Here are 2 more. 5 to the 8th times 5 to the 5th. Now the first thing they've done is show you expanded form. 5 to the 8th in red, they listed 8 copies of the base 5 times 5 to the 5th in blue, and they used the base 5 times. And then if you was using expanded form, you would have said my base is 5 and I've used it 1, 2, 3, 4, 8, 9, 10, 11, 12, 13 times. The shortcut is to know the rule, which says when the bases are the same, we keep the base and add the exponents. And then when we simplify, we end up with 5 to the 13th. The second example is similar. They're just using variables instead of actual numbers for the base. If we have x to the 6th, that is 6 factors of x, which are in red. And then x squared is 2 factors of x. And then when we combine those, you can add them together. And 6 plus 2 makes 8. You are welcome to expand these if you're not confident. I'm okay with that. In general, for the product of powers with the same base, n to the a times n to the b is equal to n to the a plus b, where n is not equal to 0. Guys, your base cannot be 0, because if you multiply 0, you are always going to get 0. It's never going to change. You can also, I can't see. We'll just go on. I can't see it to move it. All right, you can also use the meaning of exponents to divide powers with the same base. This will be on your video tonight, but this is where they go over it in the book. If you are dividing 4 to the 12th and by 4 to the 5th, that's 12 factors of 4 in the numerator. And we're dividing that by 5 factors of 4 in the denominator. You guys should remember what it was like to eliminate or cancel terms in division, like when you're reducing a fraction. If two things are identical, you cancel them by dividing. 4 divided by 4 makes 1, which eliminates or cancels it. 4 divided by 4 makes 1, which eliminates it. 4 divided by 4 cancels. 4 divided by 4 cancels. And 4 divided by 4 cancels. You do not need to write all of this out. When you cancel out the ones that will cancel, whatever you have left is your answer. We have 1, 2, 3, 4, 5, 6, 7 factors of 4. So we would keep that base 4 and we would give it the exponent 7 to represent the 7 factors. Now, all of those remaining 4s were in the numerator, which means that would have been over a 1, and we do not have to show the denominator. So 4 to the 12th divided by 4 to the 5th equals 4 to the 7th. What is the relationship between the exponents of the dividend, divisor, and quotient? The exponent of the quotient is the exponent of the dividend minus the exponent of the divisor. Now what that means is you subtract the bottom exponent from the top exponent. From the top exponent. Okay, the order does matter. Okay, the order matters a lot. In general, the quotient of two powers, remember quotient means division, with the same base is n to the a divided by n to the b, giving us n to the a minus b, where n is not equal to 0. Again, those bases cannot be 0. Products of powers. Read the problem below, then explore how to find the product of powers with the same base and the same exponent. Simplify 3 squared to the 4th. I told you guys yesterday, these sound weird when you read them. Okay, they sound weird, they look weird. It's got 2 exponents. When I read it, I have to read the exponent twice. 3 squared to the 4th. That means that I have 4 factors of 3 squared. And that's what they're showing you down here. It says 3 squared to the 4th. You'd have 3 squared times 3 squared times 3 squared times 3 squared. 3 squared to the 4th is the product of 4 powers, each with the same base, 3, and the same exponent, 2. Now, if you look down here at the rather lengthy explanation, we do not need this step, or this step, or this step, so we'll just do it my way. So if you expanded this out, you would have 3 squared times 3 squared times 3 squared times 3 squared. As these are like bases, we can keep that base, 3, and we can add those exponents, 2 plus 2 plus 2 plus 2, which would give you 3 to the 8th. Now, if you'll just use the product rule instead, or the power rule, I'm sorry, use the power rule, you would know that we keep the base and we multiply those two exponents together. So you've got 3 squared times 4, which gives you 3 to the 8th. You get the same answer. If you expand, this would be expanded using the product rule, and this would be the power rule, which keeps you from having to expand it. Top of the next page. Simplify 3 squared to the 4th. We've already said it's 3 to the 8th. Describe the relationship between the exponents of 3 squared to the 4th and the exponent of 3 to the 8th. We multiplied them together. 2 times 4 gave us 8. Complete the examples of products of powers that have the same bases and same exponents. We've got 5 to the 8th to the 6th. They're showing you expanded form using the product rule. Or you can jump straight to the power rule and keep the 5, multiply 8 times 6 to get 48. 953 to the 7th to the 3rd means we're going to use 953 to the 7th 3 times. You could expand and then use the power rule, the product rule, or you could jump straight to the product rule. Power rule, I cannot get those straight. 953 to the 7th times 3 is 953 to the 21. In general, here's your rule. In general, for a product of powers that have the same base and same exponent, n to the a to the b is equal to n to the a times b, as long as n, the base, does not equal 0. Now look at how to simplify the product of powers when the bases are different and the exponents are the same. If you look at this example, you can see we've got 2 to the 3rd times 4 to the 3rd. You can't keep the base because you would not know which base to keep because they are different. In order to combine things, you have to have things that are the same. On this one, we've got same exponents. Now, just like when I was showing you yesterday that you could distribute an exponent, you can also undistribute. If we was to pull these 3's back, okay, put these in a group, and pull those 3's off, put them on the outside, you could get rid of them in here, and you would be left with 2 times 4 to the 3rd. And then, of course, you could just multiply 2 times 4 to get 8. If you was going to write this expression out, you would have 2 times 2 times 2 times 4 times 4 times 4. What they want you to do in number 7 is to use the associative and commutative properties to write your expression as groups of 2 times 4. Well, we would pull a 2 and a 4 to make the first group. You would pull a second 2 and a second 4 to make the second group, and you would pull a third 2 and a third 4 to make the third group, which gives you 2 times 4 3 times, or to the 3rd power. How many groups of 2 times 4 did we multiply? 3. And then to complete the equation, we had 2 times 4 to the 3rd, and 2 times 4 gives us 8. In general, for a product of powers that have different bases, this is your rule. A to the n times b to the n is equal to a times b to the n as long as a or b are not 0. The base cannot be 0. Number 11, we have 2 as the base with 2 exponents, so 2 to the 18th to the 8th. That is 8 factors of 2 to the 18th. So 2 to the 18 times 8 is 144. On number 12, 4 to the ninth